sorry if you don't, I don't display my face, but I'm not in a condition to be recorded. In this video I'm going to teach you flowcharts. Well, flowcharts aren't strictly necessary when writing programs. In fact, I admit that myself, I very rarely draw a flowchart. I draw a flowchart only if my ideas are totally unclear, or if I have to submit the program to somebody else and I would like to show them how does the program work. However, if you don't mind, with 36 years of experience, it's very rare that my ideas are unclear. While people who are at the first very steps of learning a programming language, it may be easy that your ideas are very unclear. Not because of the programming language, but because you are not used to think in an algorithmic way. So, drawing the flowchart can make your ideas clear. Okay, so it can also be useful in other topics which have nothing to do with computers, because flowcharts are typically used also whenever you have a process and you have to clearly understand what is the process doing, when does it go to a direction, and you can easily spot the mistakes in your process, the things which causes delays, or the things which causes confusion. So let's start with these flowcharts. From now on, I will require flowchart very often, not only because I'm evil, but because I've noticed that some students have the tendency to put random statements in the program. And sometimes I'm puzzled. I say, but what does the student want to do here? Well, maybe with a flowchart, I hope that you will be able to at least have a direction. So your program, the program that you write, should reflect your flowchart. Okay, how do you do a flowchart? Well, honestly, I would draw the flowchart by hand, so with pencil on paper. Pencil because you are going to change your mind very often. But here I cannot do it with pencil. I tried to do it with a touchpad, but it was a mess. I found online this diagram. You can, when I ask you to do a flowchart, you can do it however you want. You can do it with pencil on paper and take a picture of it. You can use online tools such as this one, Draw.io. What is that? Let's see. Draw.io. That's it. You can use other online tools if you have there are also free programs available. Whatever you want, doesn't matter. You can use also Word if you want. Okay, let's see the basic shapes. The first shape that we see is this one. This marks the start. Usually we identify with start. Where is the start? Okay, may I zoom a little bit? The Mac scrolls in the wrong direction. Okay. Maybe I can also make the font 18. Okay. The oval marks the start and end of the program. Usually we have an oval at the start and an oval at the end. Okay. If your program is a procedure, in the start you will make it a little larger, and you will also specify start here input variables v and a, whatever they are, and if you know what they are, via string, and etc. etc. If it's not a procedure, just start as this. Then we have the arrow. The arrow marks the flow of direction, usually below. Can I make this arrow a little? No. Must be so thin. Or here. Oh, I like the thick arrows. Okay. Sometimes it will branch. Another typical symbol is this one, the rectangle. Okay, where is this is a square, but is it okay also for the rectangle? Yeah. Okay. Here this is an internal operation, so the computer does something. For example, put a value inside a variable, multiply a variable by another one, some internal operation which don't have anything to do with input and output. Then we have this symbol here. Where is it? Okay. This symbol here, whenever you have input and output operation, typically a print is an output operation. Even though some people use this one as a print, because this one produces a document. Okay, a print, or whenever you have an input operation, things you ask to the user or things you get from files, information you get from files. Okay. And then, okay, this, I think there is nothing else for the moment, except maybe this one, okay, which is necessary whenever you, when your flowchart becomes very complicated and you need to jump from one page to another one. Here, right, goes to A, and you have an A in another page, or an A in another part of the flowchart. So whenever your flowchart becomes complicated, we use this one. We will use also this one, but later on. It represents a decision. Okay, let's delete them. Let's see a flowchart, for example. Here, this is a very easy. Okay, let's see what we have here. This one is an internal operation. Okay, it's true, in theory you are inputting this sentence, but it's internal part of the program. Okay, so if I made it interactive somehow and write s equal ask the user to type a sentence, that would be an input-output operation. But since I just write it directly, it's internal part of the program. So, where is it? Where is it? Where is it? Where is it? Here. Okay. S equal S is assigned okay. I write it completely here. S is small s. Okay. Okay. Later on, now because it's the first flowchart, later on you can simply write s equal to this sentence. Okay, so for assignment you can just repeat what's written here. Okay, it's obvious. Whenever it's more complex, please don't just repeat it, otherwise your flowchart is nothing else but what you see here. Copy. Oop. Now arrow. Oh, it's big. As I like it. It's not in line with the previous one. It's because the entire... I am not so good, so skilled at... okay. Where is it? Where is it? Here. I just... T equal N. Okay. Fine. Okay, why it starts with... oh, okay. Okay, so another internal. So now I copy, paste. Okay, you can see if you're lazy. The advantage of not having to do it. Now here another I equal to 12. I is assigned the value of 12. By the way, okay, let's specify also what is what. T is a string and set to, okay. Let's make it mandatory. I is an integer, is an int, and set okay. Okay. Okay, so now let's see what does it do. Oh, finally there's a print operation. We print sfindTi. This, in theory, it's a single operation. Okay, in practice, I would split if I were you. However, let's now. So it's where is it? Input output here. Okay, we print. Yeah, but why do I write here? I would like to write here in the middle. I can't. We print s.find. What did we print? Ti. Obviously, if you do like this, it's pretty useless. But can't I write in the middle? Let's erase everything. No. So we have to find another symbol for output operation. Which can it be? This one? No. This one's for loops. This one. Let's write this one. Okay. Okay. Undo. Okay. So from now on, this will be our output. If you want, you can use the other symbol for output operation. Okay, but if you write it like this, it's not very helpful, because here you are combining two operations which have nothing to do one with the other. In practice, copy, and I have duplicate. Wow. In practice, first you are calculating s.find of t and I. Okay, or better, find occurrence of t in S after index I, and then print it. It's not very elegant to say it above. Okay. So in this way I split and I describe it clearly. Otherwise, please write something as print open parent. Otherwise, write it here. Find occurrence of t in S after index I and print it. Write it everything here. But I would like you to specify what does the print do. Okay? Because the diagram is to let everybody understand what is it doing, what is your program doing. If you hear things scratching, it's my cat. Okay, now the program ends. Where is the end? Here? Here. And okay, this is the flowchart. It's a straight flowchart because there was no decision, nothing. So, tung. Okay, now I save it. Where is the save? Save here. Okay, puff. Okay, another page. I hated the grid. Okay. Let's see another thing a little more interesting. For example, let me see. This procedure here. Okay. Whenever you have a procedure in the middle of a program, please, the procedure and the program have different. Or let's do like this. The procedure and the program have different flowchart. So here, the procedure, this one, has a flowchart on its own, because it's in practice a program on its own, and the rest, this 2 and this 3, have a flowchart on their own. Okay. by the way, it's never a good idea to write a procedure here in the middle of a program. It's much better to write it at the very beginning and then all the rest of the program, or even in another box. Okay. Can you see here, in fact, I write it at the beginning of the program and then I write print. Okay, so just because it was the first one, but it's never a good idea to write a procedure in the middle of the program. Okay, the program is a thing, the procedure is another thing. Let's write a flowchart for this procedure. So C to F. Okay, so we accept C. Where is the star symbol? Here it is. Why here? Here. Helvetica 14. Start. Input. C. Which we would like it a number. It can be int or float, doesn't matter. Okay, let's make it larger. Okay. See, see. Okay. Oops. Okay. Now, where is it? Here. Second step. We calculate f. Let me copy the formula. So we take an arrow. A calculation is done in a standard rectangle. Calculate f as okay. Okay, let's do third step, return f. So we don't even need to do anything. It's the end of the procedure. Terminator. The oval is the start, and this. Okay, you can use this one. If you draw it by hand, doesn't matter. End, and don't forget that you return f. Okay, that's it. So in the procedure, don't forget to write clearly what are you going to return here and which are the input here. Okay, this was easy. Okay, let's page view grid. Let's go to the things with the if, which are a little more interesting. Let's see, here it is. Okay, this one. What else? Yeah, this one. Okay, so only the procedure, not also the program is basically, so it has only start, output, no, start, call the procedure is friend with a parameter with argument people, and then return the result of the procedure, end. So the program is pretty trivial. The procedure, however, so where is the start? I repeat, you don't have to use do.io. It was the first one I found. So you can use whatever you want, even writing by hand. Start, what do we get? We get a name. Input. Name. Why the keyboard of the Mac is not okay? A string. Okay, I have always to blame the Mac, even when it's my fault. Okay, now arrow. I'm wondering why the arrow arrives always not in the right direction, even though I'm in flowchart, so I would expect the arrow. Okay, now if the if is indicated with this thing here. Can you see decision? Okay, it's right here. The check is name of 0 is pp, so first character of name is p. Okay, you better writing things in English directly, because otherwise, first of all, I may have the impression that you have not understood anything, you have just copied from the code. Second, you're not helping the people who are reading it. Okay, let's say here true on the right and false on the left, or you can do whatever, right? It's not mandatory. Ah, wow. Yes, but I don't want this one here. Okay. Wow. Oh, now the tool looks much better. So this one is not necessary, however. Okay, so here, how can I write something? Can I write something on the arrow? Yeah, so this is the true. And this is the false. Okay, I would prefer to write it a little bigger, but you can't have everything that you want in life. Okay. Okay. If it is true, what do? We return true. If it is false, we return false. So we have two terminations here. And return true. Duplicate. I must say that this tool is really nice. Maybe I can buy it. Okay, done. This is exactly the description of this one. Okay, save. Beef. This one has been saved. Okay, let's see another one. More complex one. This one with a leaf. Okay. This is not a procedure, it's a program. So start with the first one will be s equal Anna. Grid. Above. So we just start. We don't have anything because it's not a procedure. Op. Oh. And sorry, may I do a test here? Op. Can I change now the shape of this one? No. No. Op. I have to take this one. S, which is a string, is set to Anna. Okay, make it larger. Okay, and we don't need it so big. Okay, we don't need the arrow so long anyway. Okay, then we have immediately an if s equal Paolo. So, no, unfortunately there is this one. We have the decision here. S is Paolo. Equal, okay. In this case, okay. If it is true, what do we have to do? Print, hey, it's me. So we have an output. Where is it? The document, okay. Since the other one was not, so print, hey, it's me. larger, and then we end everything. And it will never understand that I want 14. Okay. Here we have to write true somehow. True. Okay. If it is false, to put it like this, because if it is false, the program goes on. Okay, so it's even better. And never understand. 14. Okay. Now I just copy here because Ctrl C, Ctrl V. Hey, it's Anna. Okay. If it is false, false. That's it. It checks whether it's Michael. Michael. Okay. And if it is Michael, we print hey, it's him. Copy. Paste here. It's him. Okay. If it is not Michael, what do we do? Print it's somebody else. I just copy this one, paste here. And then we end. Just copy this, copy, paste here. Okay. There is actually a little subtle mistake in this diagram. Okay. If I print hey it's me, Lee, can you see? Hey it's me. I don't immediately end. The if jumps here and then it ends. So then it's not like a procedure where here I write return whatever, here I write return, so there are different endings. If I print hey it's me, after having printed it, the program jumps here at the end. So the end for this one, the end for this one, the end for this one, and the end for this one is the same one. All happen here. So it's a little just a little technical detail. So this ends here. Technically they're not here, but this one, but I want to make it go. Don't want the text here. Let's put another arrow so it makes okay. So technically it's the same end. While if you are inside a procedure and you write here explicitly return, 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 these are 4 different endings. This one is the same ending in theory. So just a little technical issue. Okay, so as you can see, doing a flowchart is pretty easy, but unfortunately, please, you should not do it after having written the program correctly. You should do it before. It helps you a lot to have a clear idea of what your program will do, whether there are some things which don't work, things, for example, if you discover that here you don't have any plan for when it's true, well, Then when you will write a program, you will have a problem, because you must have a plan for what when it's true. Okay, so it helps you figure out what will your program do. So I strongly suggest you to draw the flowchart before to have an idea of what is going on. Okay, especially in the homework. Okay, let's stop the video. Goodbye.